Guys, I'm going to be explaining chemistry on week 10. So basically, they want the common characteristics of nuclei of the same element. Since they said same element, the protons are going to stay the same and the nuclear charge is going to stay the same. So let's say an atom had 8 protons, the nuclear charge is going to also be 8. So basically just memorize it. Okay, for this question, they want to know about ion formation. And ion formation is like when an atom gains an electron, because electron is negative. When it gains an electron, it becomes a negative ion. So it releases energy. So when you gain an electron, you release energy, okay? But when you lose an electron, you're becoming positive because you're removing the negative ions. So when you lose an electron, you're absorbing energy. Okay? So let's read. So we said when you gain an electron, which is negative, so you're forming here, energy is released. That's true. And when a positive ion is formed, which means a proton is formed, so you basically lost an electron, you're absorbing. So to be honest, memorize it. Okay, here they want to know about the electrons in an isolated atom. First, what's an isolated atom? Isolated by the name, it means it's alone, like it's being isolated from every other thing. So an isolated atom is an atom that is like it's not bonded to any other atom, so it's just alone. You have to memorize that the electrons in an isolated atom move randomly, like they don't follow a fixed path, they just move around the nucleus. Okay, for this question we have to memorize it. It says they want what determines the chemical properties of an element. The answer is atomic number. The atomic number is basically A and then C. This is the mass number, and this is the atomic number. So this determines the chemical properties of an element. Just memorize it. Okay, for this question we're comparing the mass. So we have to know that the mass of proton is 1. And then the mass for an electron is 1/1840. And then mass of a neutron is also 1. Also keep in mind that we're talking about mass. Okay, if they said they want the charge, that's a different thing. So now we'll go back to the question. So the mass of the proton, which is 1, is equal to the mass of the neutron, and we said neutron is also 1. Exactly. And then we said electron is the only different thing in mass, which is 1/84. Also, the mass of an electron is negligible. That's all you need to know. Okay, this question is also memorizing, but I'm gonna try explain it, kinda, I guess. So they're saying the atomic diameter is the distance between 2 nuclei in solids. What is the atomic diameter? Imagine an atom and you're measuring the width. That is the atomic diameter. Okay, so we got that. And it is found to be in the order of 10 to the power -10. So that means it's like 0.0000000 and so on 1. So you just have the way to memorize it is atomic diameter is the distance. Easy. it is found in the order of 10 to the power negative 10. We know atoms are really small. You can't see it with your own eye. So since they're really small, it's 10 to the power negative 10. Okay, in this question, they want the definition of a stable nucleus. So first, what is the meaning of stable nucleus? From the name, it doesn't break apart, it's stable. Okay, and what they mean by it can exist indefinitely, that means the atom stays the same and it doesn't change into another element. So yeah, just memorize it. Most of this quiz is memorizing anyway. I explained this many times before. You use the NCV rule and you use the MC times V molar mass rule and just apply them. Okay, for this question we're gonna drop and switch. So here they have opposite charges but same number. You can cross them out, so it's just gonna be an MgO. Here it's the same thing. This is 1, this is 1, because when you have a charge but no number, it's basically 1. You're gonna cross them out. It's gonna be NH4Cl. Okay, those are really easy. Okay, now here you're gonna drop and switch because they have different charges and different numbers. You can only drop and switch, by the way, when you have one capital letter. If you have 2 capital letters, you can't drop and switch. So the 3 is gonna go here and the 2 is gonna go here, so it's gonna be Ca3 and N2. Okay, and then here you can drop the 3 here and you can drop the 2 here. But when you drop the Al2, when you drop the 3 to CO4, is it gonna be CO4 3? No, that's very stupid. So you're obviously gonna put brackets, so CO4. See how those are, CO4 is capital letter. You're not gonna drop the 4. So then you're gonna put the 3, outside. That's it. Okay, you have to know that A is the mass number. I already wrote this. And Z is the atomic number. Okay, so that's what part A is asking for. A is the mass number, Z is the atomic number. Memorize it. Now for part B, basically you have bromine and you have 80 and 35. So you have to know that the number of protons is 35. So atomic number equals protons, okay? So whatever is down, it's protons. Now number of neutrons, you're gonna minus the mass number minus the atomic number. So 80 minus 35 equals 45. So that's the neutrons. You have to minus the mass number minus the atomic number. And then the number of electrons. Number of electrons is the same as number of protons. But if you had a charge, let's say this was -2, you would add 2 to the number of electrons. But if it was +2, you would -2 from the number of electrons. So yeah, but in this case you don't have any charge, so it's gonna be 35. It's equal to the protons. That's it. Okay, here we need to fill this in. Okay, let's do the easiest one first, which is protons. Protons, you just have to look at the bottom number. So 17, 13, 11, and 16. Okay, that part is really easy. We do the protons first. Now we're gonna do the neutrons. The neutrons is all of this minus each other. Okay, so 35 minus 17 is 18. 27 minus 13 is 14. 23 minus 11 is 12. And 32 minus 16 is 16. That part is also really easy. Now electrons. Like I said, if there was nothing here, it would be the same as the protons. But since there is something at the top, then you don't put it the same as the protons. So let's zoom in. see how here there's a -1? You're gonna do the opposite. You're gonna add, so you see the protons, which is 17, you're gonna add 1, so it's gonna be 18. But let's say, let's say this was +1, you would minus 17, like 17 minus 1, so it would be 16. Okay, we'll do more examples now. So now here, you're gonna look at this, you're gonna look at this. 13, since it's plus, you're gonna do the opposite. You're gonna minus 3, so equals 10. Easy. Next. Now 11, you're gonna take 11. It's a +1 here, so -1, so it's also equals 10. Then here, you're gonna take 16. It's 2 minus, so +2, so it's gonna be 18. And that's it for this table, really easy. Okay, this question is really easy. So they want what represents an atom. An atom is proton equals to electrons, okay? So which one of these have the P and the E the same? So here the P is 1 and the E is 1, so A is correct. Here you have 1 P and 1 E. So 1 P, 1 E, so this is also correct. Here you have just a P, so this is wrong. Here you have just a P and there's 2 E's, so it's also wrong. Here you have 2 P's and 2 E's, so this is also correct. So A, B, and E. Okay, now what represents a positive ion? A positive ion is proton, right? Proton is positive. So what has more P's than E's? So here you have just 1 P, so obviously it's gonna be C, so it's positive. And then the last part, they want negative ion, so there has to be more electrons, which is negative, than protons. So here they're equal. Okay, we're gonna ignore these because they're equal, and we're gonna look at these. We said this one is positive, and here look, there's more electrons than there are protons, so this one is the negative ion. Okay, here they're saying the number of protons in an atom is represented by, like I said, this one is A, this one is Z. The number of protons is the atomic number, and the one at the bottom is the atomic number. So Z is the proton, so atomic number, that's easy. And then for part B, they said they want the atomic numbers too. You have to know that atoms or atomic number is protons equals electrons, and they want it 2 times. So here protons and electrons are equal. This is correct if they said atomic number is 1, but they said atomic number is 2, so it doesn't work. Here they said electrons, electrons, protons, protons. So the atomic number is 2 here. Here there's electrons, electrons, and 1 proton, so no. Here they said 1 proton, 1 electron. These two are the same. Like I said, if they said atomic number 1, those would be the answers. Okay, for part A, like I said, this one is atomic number, this one is mass number. Mass number is the number of protons and neutrons in its atom, and atomic number is the protons. Okay, so mass number, easy. Now for part B, they gave us this. We know that the protons are now 1. Okay, so let's start. Here there's 2 protons, so this is wrong. Here there's 1 proton, so this may be correct, so we're gonna keep it. This one also 1 proton, so we're gonna keep it. This one is also 1 proton, so we're gonna keep it. Now since there's no like -1 or +2 or whatever, there's gonna be one electron, right? Yeah, 1 electron. So here there's 2 electrons, so this is not gonna work. Here there's 1 electron, so this may work. Here there's 1 electron, so this also may work. And obviously there has to be a neutron, so this is gonna be the answer, and this is not gonna be the answer. That's it. Okay, here they gave you this. You're gonna balance it, so you're gonna write CrNO3 and you're gonna balance. So you're gonna write Cr plus NO3. Now we're gonna take this here, not to Cr, you're gonna take it to be the coefficient of NO3. So it's gonna be 3NO3. Now, they're saying there's 0.5 moles of the, basically, these are the moles, right? So there's 0.5 moles in all of this. So you're gonna do 1 times 0.5 and 3 times 0.5. So the coefficient times the number they gave you. So this is gonna be 0.5 and this one's gonna be 1.5. Okay, this is also really easy, because they give you all of this, but they don't give you the 3. All you have to do is take this as the coefficient, so 3Cl, and yeah, that's it. Okay, this is also really easy. You have to memorize it. Atoms have a positively charged nucleus. You have to know the nucleus is always positively charged, and they said negatively charged particles are called electrons. Okay, that's easy. And then we already got a question that atoms have a diameter, obviously, to measure the width of the atom, and in the order of 10 to the power negative 10, which is 0.00000 and so on till you reach 1. That means the atom is really, 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 really small. And yeah, memorize it, that's it. It's also really easy. The nucleus is positively charged because it contains protons and neutrons. Protons are positive and neutrons are neutral. And yeah, that's it. Okay, so we know that electrons are negative and electrons are negative. So if they gained negative charges, the atom would be negative. But if it lost negative charges, the atom would be positive. Very easy, common sense. Okay, this question you memorize. Protons and neutrons are made up of quarks. That's it. Okay, this question is really easy. So let's draw the X and the A and the Z. Obviously, we know A is mass number, Z is atomic number. We got that by now. We know mass number is protons and neutrons, and atomic number is just protons. So they said 7 protons, so we know that the 7 is gonna go down. And they said 7 neutrons and 7 protons, and we know that mass number is protons plus neutrons. So it's gonna be 7 plus 7, which is 14. That's it. Select the symbol that represents the number of nucleons of an atom. It's gonna be A because Z represents the number of protons and A represents the numbers of neutrons and protons. This came many times and we probably all have it memorized by now. Crystallization, you use crystallization when you want to separate a soluble solid. The tools you use in crystallization is Bunsen burner, an evaporating dish, wire gauze, and a beaker. Memorize it, I'm not going to explain it. And the crystallization processes, you have to have them memorized as well. So you're going to warm the solution over a steam bath, obviously. Leave the solution overnight till it all evaporates. And yeah, heat the solution till most of the liquid evaporates. Memorize it, this also came many times. Okay, we're back to really old questions. I'm just going to remind you guys what to do. So they want the moles, and the rule for moles is N equals M over molar mass. They gave you the mass, which is 17.6 over the molar mass of C3H8, so it's 44. The answer is 0.4. For the number of atoms equals moles, which you got here, 0.4 times Avogadro's times atomicity. Mole is 0.4, Avogadro's is this, and atomicity is 3 plus 8, it's 11. You're gonna put that on the calculator, you get this. That's it. Okay, this is also really easy. They want the moles, and there's another rule for moles. It's molecules over Avogadros. So the molecules is 9.0 times 10 to the power 21 over 6.0 times 10 to the power 23. You put that into the calculator, you get this. Actually, no, you don't get that. I just put it in the calculator. You get 0.015. But you can do this, and when you go that way, it's negative. So 1.5 times 10 to the power -2, because you move twice. Okay, and then part B. So to find the grams, the rule is M equals moles times molar mass. The mole is here. You're gonna put that times 16 times 2, because it's O2. It's gonna be 32. You get 0.48, and that's the answer. Here we're gonna write down the equation. They said H2O2. H2O2 gives you H2O plus O2, and this one is gas, this one is liquid, this one is also liquid. And then you're gonna balance, there's a 2 here, there's a 2 here, there's a 2 here. You're gonna add a 2 here, and you're gonna add a 2 here, and it's balanced. That's it. Okay, here, we're just gonna balance. It's really easy. So here, what's common between 2 and 3? It's 6. So you're gonna add a 2 here, and you're gonna add a 3 here. Then it's balanced. Then Fe needs a 2, and that's it. It's balanced. You put that in. I do balancing really fast. Okay, and then here, how many moles of chlorine are needed? Okay, let me rewrite it. 2Fe plus 3Cl2 gives you 2FeCl3. Okay, so how many moles of chlorine? So they want chlorine, so 3 over question mark. And then of iron chloride, they want 2 over 6. You cross multiply, you get 9.